Let's talk about the preparation and reactions of acid anhydrides next. For the most part, this will be pretty familiar territory as they react in most cases analogously to acid chlorides. Before we can talk about their reactions, however, we do have to talk about their preparation. If I wanted to make the compound on the right, which is known as acetic anhydride, I could make it from acetic acid. Now, the reason these are called anhydrides is that if you imagine this reaction happening, overall you've lost H2O or water here, so anhydride is a Latin root for without water. So technically this is a type of dehydration reaction. The way we do this is we just heat it up, and I mean a lot. So in order for a carboxylic acid to form an anhydride, it needs to be heated to somewhere near 800 degrees centigrade. As you might imagine, these conditions are not exactly gentle, and this is really only useful for simple anhydrides that can stand such a high temperature. Most anhydrides are not manufactured this way. If we wanted to make anhydrides in the lab, the more useful way would be to prepare them from acid chlorides. So the way we do this is we take an acid chloride, treat it with a carboxylate salt as a nucleophile, and form the anhydride kicking out chloride as the leaving group. This is a way to make both symmetrical anhydrides, where R1 equals R2, or asymmetrical, which are also known as mixed anhydrides, where R1 and R2 are different. The thing to note for these when they react is that they lose acetic acid or some other carboxylic acid as a leaving group. This leaving group is not quite as good of a leaving group as chloride, which is why these are slightly less reactive. Let's talk about their reactions. In most cases, their reactions are directly analogous to acid chlorides, so instead of walking you through this, I'm going to have you practice. Here's a flowchart like the one we did in one of the previous videos for acid chlorides. Go ahead and fill this in for the anhydride. Imagine that this thing in the middle, acetic anhydride, reacts the same way as acetyl chloride would, and fill in all the reagents and reactants here. Take a moment to do this, then come back and we'll compare notes. Alright, so starting with formation, we can start with the acid chloride and make the anhydride by treating it with a carboxylate anion. The anhydride can then make an ester by reaction with an alcohol, an amide by reaction with an amine, an alcohol by reduction with lithium aluminum hydride, an aldehyde by reduction with our bulky reducing agent, a tertiary alcohol by reaction with excess Grignard reagents, a ketone by reaction with a Gilman reagent, and a carboxylic acid by hydrolysis with water. All of these reactions are directly equivalent to the reactions of acid chlorides that we saw in the previous video. How about reactions? Let's say I took this compound here, which is salicylic acid, and I treated it with acetic anhydride. AC2O is a common abbreviation for acetic anhydride, and reactions of acetic anhydride to add another group are known as acylations specifically. If I did this reaction, I would get this compound, which I could then call acetyl salicylic acid. Notice that the acetyl group here is also referred to in the new name of the compound. You might be familiar with acetyl salicylic acid. This is called aspirin. If you ever have the opportunity to smell a very, very old tablet of aspirin, you might notice that it smells like vinegar, and that's due to the reversal of this reaction. The cleavage of this ester will give acetic acid as a byproduct. So time to practice a little bit. Let's say I have this compound here, which is para-aminophenol, and again I acylate it by treatment with acetic anhydride. Which one of the two groups in this molecule will get acylated? Will it be the alcohol or will it be the amine? Take a moment and think through this, come up with a good explanation, and then we'll talk about it. So in our analysis of this reaction, the major consideration is that the amine is going to be a better nucleophile than the alcohol. So amines are acylated selectively over alcohols in compounds like this. When we make the product, we might call it para-acetaminophenols. We've again inserted the acete group to indicate that this has been acylated. We could call this acetaminophen for short, or for shorter, we could just call it Tylenol. Cyclic anhydrides react a little differently from their acyclic cousins, so their reactions are worth looking at in detail. If I take this anhydride here, which is succinic anhydride, and I treat it with an alcohol like ethanol, I'm going to open up the ring, producing an ester at one end and a carboxylic acid at the other. We can do an analogous reaction if we have a secondary amine to produce an amide and a carboxylic acid. This would be really great mechanistic practice to show the mechanism for a reaction like this. Primary amines react a little bit differently. Since the primary amine has two hydrogens that can be lost, we're actually going to form a cyclic amide. This type of cyclic amide is a little special, and it's also known as an imide. This is very typical for the reactions of primary amines with cyclic anhydrides. So take a moment now to do a little bit of practice by predicting the organic products of all of these reactions. Now in each of these, there are two organic products that are formed. I want you to draw the products of both. Take a moment and do this, and then again we'll compare notes and make sure that your work is correct. In the first reaction, we have a secondary amine reacting with an anhydride. This will give us an amide and a carboxylic acid as a leaving group. In the second reaction, we have an acyclic symmetric anhydride plus an alcohol. This will give us an ester and a carboxylic acid. The third reaction is acylation of an amine. And the final reaction is the reaction of a primary amine with a cyclic anhydride. This will give us an imide and water as a byproduct. Note that water is not an organic product. I just felt like showing it here for good measure. Make sure you're familiar with the chemistry in the anhydride section of the book. Next, we'll be moving on to discuss esters.